So, looks like we are live. Hi, Rahul.
Hey Alex, how are you?
Oh, good. I'm happy to be here with you, and I'm happy to be with all of our guests here today with you. So, welcome everyone. Let me check how it goes for us, and if you can hear us, if you can see us, please set the thumbs up in the YouTube chat, and I will know we can start. And looks like we are good. Yes, we are good. And we can start smoothly but surely. So, what do you have for us today?
Well, Alex, thanks for having me back again. It's good to see all of you. Today we're doing a second presentation in a series of three. Today we're going to be talking about how to do a migration. Really, the same methods could be used in any type of database migration, but specifically when you're moving into a serverless cloud database, how do you prepare for it? We talked a little bit about that last time. Today, we're going to talk about some nuts and bolts of actual tools that we could recommend and some methods on how to do that. But yeah, that's pretty much it. We'll get into the nitty-gritties in a minute.
Right. Migrating an application or managing services is, well, at first I wanted to say much easier than the database or data layer, but maybe it's not the right way to call it. It's not easy in no way, but despite the application migration is not easy, data migration is way much harder anyway.
It is. It is
Yeah,
absolutely. But let's go ahead and get started.
yeah.
Hey, everybody. My name is Rahul Singh, and I am a leader of a small boutique Cassandra consulting team. I also, as part of my work, and I love doing it, am the creator of Cassandra.link and a maintainer of Awesome Cassandra. So if you want some authoritative, well-curated links, I take a lot of effort and pride in finding the best links on Cassandra and putting them there. And then I also maintain a few other ones just because they pique my interest. Another thing that I do, which is again I love it, is organizing and managing some meetups in the Washington D.C. region. You may have found some of the Data Wranglers data engineering lunch every Monday at noon, and we also have Cassandra lunch every Wednesday at noon, both times Eastern Standard Time. Alex?
Yeah. So, what we are doing today and what you need to know about our workshops, webinars, and all the other events we are doing. You mostly probably now watching us as a live stream on YouTube, and that's a primary channel for us. In case you have any problems with YouTube or you just prefer Twitch, you can switch to Twitch. It works. We have Twitch as a backup platform, DataStax developers channel. But YouTube is a primary channel for us, so we don't monitor, we don't answer questions on Twitch. Speaking about questions, you can ask your questions right in the YouTube chat, and it's a live event, so we are happy to get your questions and answer them. But as soon as this workshop is over, as soon as the stream is over, questions are gone forever and answers as well. So we suggest you to join our Discord at bit.ly/Cassandra-workshop and join the huge community fellowship of the Cassandra Rings with a great bunch of incredible developers, engineers, administrators to have fun, to chat with, ask questions, answer questions, and share your knowledge. Then, um, today, in the second part of this workshop, we are going to run a quiz, a competition where you give questions, give the answers to our questions. If you do it right, if you do it fast enough, you will get prizes from DataStax. That's incredible. And today, as the base for the data migration, we will use Cassandra as a service, which is a DataStax Astra DB, but we will talk a bit more about that a little bit later.
Awesome. Very cool. Thanks for getting everybody in order. Just back to the presentation. As I mentioned, this is a second presentation in a series. Last time we talked about planning migration, best practices. Today we're going to talk about the actual data migration, some best, some patterns, and then some tools, some methods to use. And then next week we're going to talk true transformation, which is how do you really create a truly serverless platform that is as much in the cloud as it can get, basically, without you having to worry about any hardware, any infrastructure at all. So what do we want to get out of today? Well, we're going to do a little bit of a recap on what we talked about last time. We're going to talk about a few migration patterns, and we're going to talk about four tools that I think are going to be very helpful. There are other tools, and I'll mention them likely, but I'm going to point out some resources for DSBulk, for Spark, Liquibase, if you haven't heard about it, for schema management, and Airflow, which is one of my favorite tools these days, and how to really use that. And I've organized the tools in a way so that you can start to kind of build up how you would use each in a different scenario. And then finally, at the end, when we look at Airflow, you'll understand how you can tie all of these things together with Airflow. And I'm not going to go through the hands-on exercises, but every single topic, there's going to be a link, and I'm going to give you the location of the links. There's also some resources where you can find in-depth articles on how to use every one of these tools. So don't worry about, copying and pasting links. Just focus on the talk, and if you have questions, please ask them. Alex will relay them to me. I want to thank the sponsors. A lot of the examples that we use are hosted on Gitpod. Gitpod is a serverless, goes with the theme, right? Serverless IDE. And DataStax, of course, helping with this workshop and also providing you guys with free Astra databases to play around with. And of course, my company, Anant, which is providing the content and the source code for you guys to use. I'm an architect. What is an architect? Well, it's a noun and a verb. Architect means chief builder. I'm actually in Greece. I was in Greece last week, and I'm in Greece this week. I see actual architect, and it says architect dot. Well, what does it mean? Architect means chief builder. But in computing, architect means to design or make. Well, at our company, Anant, we architect platforms on Cassandra and related technologies. We'd love for you to join our team as an engineer, operator, or if you're an architect. What do we love doing? We love scalable, fast data, and that involves Cassandra. If you're doing anything with big data and it's fast, of consequence, you're probably using Cassandra at some point, and you're probably using Spark, and you're probably using Kafka. Well, that's what we play around with, and DataStax is a great partner. We love using all the tools and technologies that they provide.
Thank you.
There's a link. You're going to see it a few times, but it is a shortcut to actually an index page on our blog, which has then 6 articles on in-depth how to use DSBulk, how to use Cassandra with Spark for data migrations and things like that. So I will mention it again, just bit.ly/Cassandra-DataOps. Again, that's bit.ly/Cassandra-DataOps. And in each of those articles, by the way, are also links to the actual code if you're curious. All right, so a quick recap on what we covered last time. Well, like most people, I remember things in the form of stories. So the story that I'm going to retell is how we as a team have been migrating our application to a completely serverless platform. And what we started off with was a set of tools that we were using running on VMs and then on containers, and then eventually migrating them into serverless systems such as Netlify and Vercel for the front end, some search indexes that are managed separately now. We were in the middle of migrating our APIs to talk to Astra and hosting our own API layers. And at this point, Astra has its own API layer, so we don't even have to worry about that. Serverless transformation, like any application transformation, requires a lot of planning. And we talked about the fundamentals of how do you document your infrastructure. Do you understand the infrastructure layer? Do you understand your your databases, your interfaces, and your software logic? Where does this all sit? And finally, what we really talked about was making a plan for your applications and your services, and then managing that change using DevOps and DataOps. We also emphasized GitOps as a foundational methodology or strategy, whatever you want to call it. Getting your DevOps and DataOps sound from the very beginning is a must when going into a transformation. It's not just for serverless transformation, it's for any transformation. And we're going to talk about the same theme today because some of the tools we're going to be talking about are useful in DevOps and data operations. We also talked about Astra, and actually Alex will talk a little bit more about it. Astra is a...
Yep. Astra is the Cassandra as a service, or better to say, heavily based on the Cassandra, providing Cassandra API as a service, which is perfectly right. Which is perfectly right for many, many kind of businesses and projects. Cassandra offers great features, but there is always a problem of the story what you have to maintain it. You need to manage servers. You need to maintain servers and operating systems and all the patches, security things, networks, and so on and so forth. So there's a stockpile of work if you want to take care of your own cluster, especially for multi-DCs, for multiple data centers. That's quite a lot of work. And most of the people, most of the businesses just want to have some database available, always fast, somewhere, but they don't want to maintain it. They prefer to develop something and bring some value to their clients. So that's exactly what AstraDB offers. It's Cassandra in the cloud on multiple data or multiple cloud providers of your choice, but managed and taken care of by DataStax. So for many people, it's almost valuable because it suggests no operations. It's all of us. It's all on us. It's serverless. It's a global scale, security, and so on. And meanwhile, there is no lock-in because you can use a cloud provider of your choice, or you can migrate flexibly. But also for developers who want to try something new, who want to learn something new, and for startups, those want to use cloud database as a service, but not ready to pay. It is free to use, even for small production workloads. And definitely free to use for educational purposes, for self-educating, for running a small project, test project, checking something. That's completely free to go, and we don't even ask for credit card. So I like it.
Excellent, thank you. And can you tell me a little bit about Stargate? Because I think it's fairly, I mean, I know what it is, but, and of course, Astra is powered by it, but can you talk a little bit about Astra's Stargate layer?
Yep, Stargate is a great thing. Basically, yes, that may be very important for many projects because sometimes you want to have Cassandra for its reliability and many other great features, but then you don't have time to teach all your team to use how to use SQL, Cassandra query language properly, and sometimes you just want to throw some data in the database, get it back, and don't want to think about the data modeling and so on and so forth. With Stargate, which is an open source technology, so you can use it with your own Cassandra deployments completely, and it's enabled by default for Cassandra as a service AstraDB. It provides multiple different APIs of your choice with still Cassandra as a storage, but you can work with it using a REST API, like you would normally work with any kind of a backend. just the storage, based REST API, GraphQL if you prefer something more advanced, document API like MongoDB if you prefer the flexibility of schemaless or flexible schema um, data model. And that's what Stargate does. So Stargate is a great tool, and I love it actually. The flexibility, what it gives, it's incredible.
Awesome, thank you. Yeah, Stargate's really one of the gems out there in the open source world, showing how to not just make a good API layer, but to make an API layer that is useful for many people in the organization. And if you've used Cassandra in production, once it starts to get some traction in the organization, people want to put more and more services on top of it. And Stargate's the type of thing that actually makes it a lot easier for more people to use. So a very cool tool. And if you're using Astra, it's already part of it. So if you want, you can go ahead and make an account. If you haven't made an account, as I mentioned, we're not going to do a lot of the hands-on stuff, but it is something that if you haven't made an account before, takes a few seconds. As Alex said, no credit card needed. Just check it out. Just play around with it. We're going to talk a little bit about data migration patterns. Migration patterns are, again, not for just transforming an application. You may have to move data from one system to another, and these migration patterns still apply. The reason we talk about these patterns as patterns are that it's not just a specific piece of code, right? It's a way of doing things. There's a pattern of doing things, and you could change it. You don't have to do it exactly the same way. First and foremost, I would say this is the most advanced, is to do an event-sourced architecture. An event-sourced architecture requires you to have your software built in such a way that you send all of your updates to a queue. All right, and as the event processor takes the item from the queue, it can then write that to the first database. And if you have a second database that you're migrating to, right? So if your first one is your regular MySQL database that you're transforming to Astra, or if it's Cassandra database you're transforming to Astra, your event processor would write to both places. And we talk about the Astra migration service. We're going to come back to this concept in a second. But at the end of the day, if you don't already have an event queue built into your software, either with Kafka or Rabbit, if that's what you use, Google PubSub, whatever you happen to use, right? SQS, it doesn't matter. If you don't already have an event-sourced architecture, this is the hardest thing to achieve, which is to then change everything to event-sourced architecture. I mentioned this because if you're building new software and you look towards event-sourced architecture, it makes migration much easier. And the reason is that if you are storing all of your messages in your event-sourced system, or, by the way, it doesn't necessarily have to be in a queue like RabbitMQ or Kafka. You could have all of your quote events going into a table, and you can replay those events into one database or another database, or simultaneously process them. And that's really what an online migration involves. No downtime, right? Your users are not going to know the difference whether they're using the platform that's running on the new database or the old database, because you can change the load balancer to point to one or the other. And when they're using the application, there's no difference necessarily between the processing to A or B. This is new concept to you. Look up event-sourced architectures or event-driven architecture. You can also look into something called CQRS, Command Query Request Segregation, and really good article by Martin Fowler on it, who's one of the gurus in software architecture, that explains why CQRS is useful. And CQRS is basically the only way to build really, really, really large-scale applications. Moving on, this is something that most people are likely to do if they want to do a no downtime online migration. And that requires some code changes. Normally you would be writing to your old database, right, and reading from your old database. And at some point, you move your schema to your new database, A. And at that time, you would like to use both databases, right? You want to be able to write to B, your old database, and to your new database, but you're reading from B because that's where most of your data is. And at some point, right when you start doing that, we're going to move some data, right? And this is involving some offline tools. We're going to cover that in depth today. This mass movement of data, we're going to have to do that at some point, right? Just because you started using Astra, your data just didn't magically go from your data center, from your old database, your current MySQL RDS database to Astra, right? This doesn't magically move over. At some point, you have to actually move the data over. So this mass movement of data is generally done using offline methods, unless you're using event-sourced platform, and even then, you're going to do a mass replay of that data. And at some point, after you move the data, you're going to have a continuous cycle of validation. And as you validate, you may do some syncing of the offset. Okay, and this operation here, the migration of the schema, the movement of the data, validation of the data, and doing the syncs of the offset, all of this, if you don't have automations, you have to do it manually. So just keep that in mind when we start talking about some of the tools, right? And as you can see, this is a multi-step process that doesn't just involve one database. This is likely the same for every single table, every single service. So if you have 5 tables, right, imagine how much work you're going to have to do this. So the tooling is important, right? Exactly what to use, but how you do it, how you run these tools, do you do it manually? Do you do it with automation? That's also important. And this is why I was talking about DevOps and data operations before. Because if you don't have the tools in place, this type of change is super, super hard. And even if DataStax is helping with the Astra migration service, you still have to do a little bit of this. Right? You still have to do a little bit of this. Finally, offline migrations. This is the easiest way to do a data migration, but it involves some downtime.
Sorry, I wanted to say here a moment. If your business can afford downtime, that's the only one right way to go. For real, there is no jokes. It's so much easier. What it will save tons of work time on adjusting your software for online migrations when you don't need downtime. If you can afford downtime, it's like the easiest way to go with. I prefer, of course, zero downtime migrations, but I love challenge, and I prefer to work for companies who go with zero downtime approach. But in general, yeah.
Absolutely, and this is the this last one is involving dual writes, right? You're writing to the old and the new database. In this one, you're doing dual writes. So in an offline migration, you don't do dual writes. You write to one database, you stop your service, you move your data, and you switch over your application to talk to your new database, and then you're on. And by the way, this process is not just for the database too. You could do this for new services, new iterations to your software. But the point I'm making is these tools that you use for offline migration is the same tool you use for moving your data in mass in this online migration. Because at some point you have to move the bulk of the data, right? And you have some continuous process to then synchronize it. Here, you're doing it through your application. Your application is doing the dual writes. And then every now and then you validate and you sync some offsets here. But for the most part, your application is doing that for you. But here, you're responsible for it 100%. Again, this link, bit.ly / Cassandra-DataOps has all of these different tools outlined. We're going to cover a few of them. We're not going to cover every single one of them. We're going to talk about Spark in general, but there's like 3 ways to use Spark, right? We're going to talk about DSBulk, but there are some very specific code samples on the Gitpod example that you can check out. Here are all the different offline methods. I'm not going to go through them in depth, but I'm just going to go through them because I feel like this is fairly exhaustive. SQL copy. So there's the SQL sh command copy, right? If you've taken any of the DataStax Academy courses, you know how to use it because they have some really good examples. You can take data out using SQL copy and put data in. Don't recommend it in production. Because at some point over a gigabyte, I think it starts to be problematic. But it works for small workloads. It will work on Astra too. Spark jobs. So Spark jobs are, again, Spark is a big tool. We're going to talk a little bit more about it. But it's probably if you're running a big application and you have services and you have data operations, you probably have some Spark jobs there. But at the end of the day, a Spark job could be a part of your deployment to move data or to migrate data. It's compiled. A Spark script is either in Python or in Scala. You can make changes to it. You can do this pretty quickly. There's a tool called Spark Migrator. Google it. It's a compiled product where you define your from and to. Somebody actually made it to migrate away from Cassandra, but it works perfectly well between Cassandra, especially from Cassandra to Astra. Super cool tool. SS Table Loader. Again, this is the part of this managing a cluster that Alex was talking about that nobody wants to do, right? People use SS Table Loader for backup and restoration. If you're going serverless, you're probably not going to use it. And then finally, DSBulk. DSBulk is like a Swiss Army knife. It is way more powerful than SQL copy. It's out there. It's free. DataStax is giving it away. Use it. It doesn't just work with DataStax. It works with Cassandra, period. And it has support for CSV and JSON data. And you can use DSBulk with SED and awk to manipulate data in flight. In fact, one of the examples exports data using DSBulk, manipulates it in the Unix pipe using SED and awk, and then pipes that into another DSBulk to import it into another database. So you can do that type of stuff with DSBulk if you're interested. And again, all of this stuff, unless it's scripted and it's managed in some sort of operational tool, you're going to have to do it manually, right? So every single thing requires some change management and some DevOps. We're going to talk about that later. DSBulk is probably my favorite tool for moving data between Cassandra clusters because it's not only powerful, it has a configuration engine where for every major migration, you can have a set of migration configs so that you know exactly what's happening when the data is coming in and coming out. It works with Astra, it works with DataStax Enterprise, it works with Cassandra 2.1 and later. There are a few people that I know that are using Cassandra 2.0, but most people use Cassandra 2.1. So you can definitely use DSBulk. Load data, unload data. Some people will actually use it just to count. I just want to count how much is, with this query. Without running Spark, you can get an accurate count for a large amount of data. And the more you learn how to use DSBulk, the more you're going to appreciate how well it performs with large amounts of information. As I mentioned, you can talk directly from a database to a file, and then from a file to a database. Those file formats being CSV and JSON. Standalone tool, right? It doesn't necessarily have to be a part of your actual stack where the database is. You can run it literally on Jenkins server or Airflow server. It doesn't really matter. It's agnostic from where the database is. It can connect to the different databases. And lots of options. If you go to the repository, which I will quickly show, This repository you can open up in and just clone it. And if you have your Astra account set up, it will show you how to load your data. In this case, we're using a Dockerized Apache Cassandra to move data out of that Cassandra into Astra. Really in-depth article here, code here with good documentation. Take a look at it. Highly recommend learning DSBulk if you're in the Cassandra world.
That's indeed a great tool, and I'm very happy what it's finally available for Apache Cassandra, because it was originally locked on DataStax Enterprise, and frankly speaking, I believe now it's much better when it supports all the sides of Cassandra, including DataStax Enterprise, but open source Apache Cassandra as well. That's the right thing. That's the right way.
Yeah, absolutely. And there are different tools that you're going to encounter that commercial companies put out there, open source people put out there, but ultimately there's people getting paid to do the work, right? There's tools like Medusa and Reaper, for example, from the TLP people that are now part of DataStax. But it takes some quality product developers to make those tools. So I'm glad that DataStax put in the time and effort in building it, and now that it's open source, it is available to a lot more folks. Definitely check it out. Worth it. Spark. I was going to say it's a toolkit, but it's actually a whole garage full of tools, not just one toolkit. Spark is a very powerful ecosystem to deal with data. Migration is just one part of it. As I was mentioning, you could have a Spark job as part of your deployment to be managing mass data migrations, offset migrations of data in very kind of elegant and complex ways. We're just going to cover a few of them. So if you're a Spark master, no pun intended, you are going to probably have better ways of doing what I'm suggesting here. If you don't know what Spark is, it's kind of like the next generation after Hadoop, and it is so widely used that if you don't know Apache Spark and you're in the data world, in the big data world, I would question what you mean by big data. Everybody uses it. Apache Spark is part of DataStax Enterprise. It is also part of every Hadoop distribution. It is available on Google Dataproc, on Amazon EMR, on Azure HD Insights, and then Databricks, of course, commercially supports it. We covered these different variations of Hadoop and Spark availability on the Google, Amazon, and Microsoft native clouds. But it's basically an API to manipulate a DAG. And we're going to talk about DAGs a little bit later as well. DAG is a directed acyclic graph. So you have a sequence of tasks you need to do. You define it in code, and then Spark takes that and breaks it into smaller chunks of work, and it spreads it out into as big of a cluster as you have. If you have a 6-node cluster, it'll do it on 6 nodes. If you have 1,000 nodes, it'll do it on 1,000 nodes. And it will do it, and it will finish the task. So if you have to move terabytes of data, you kind of have to maybe start thinking about Apache Spark. Right? Yep. DSBulk may or may not be able to cut it for you.
Yeah,
you can try.
Spark is an incredible thing. It's very powerful and has very many of different possible usages. It supports very many different scenarios. It's a very, very powerful and configurable tool. One of the usages of Spark, not for migration purposes, although maybe for migration as well, is Spark SQL. So you can, for example, run SQL queries over Cassandra, which is NoSQL, but with Spark you can have SQL over SQL, which is quite cool. Of course, it's not going to be as lightningly fast as Cassandra is, but there are some places here to have this ability, which is quite interesting. We have a question from Rahul. Rahul Poyak, hopefully. Spark, what is a Spark to compare to any another tool used by developers, what would you call a Spark competitor, for example?
A Spark competitor. Compared to Spark, there is Apache Flink, which is also open source. Compared to Spark, in the Google ecosystem, there's something called DataFlow. And connected to Spark, there's a thing called Apache Beam. And Apache Beam actually runs on Spark and on Flink. Anyways, it's all kind of connected. But Apache Beam, Apache Spark, Apache Flink are kind of not really competitors because you can run Beam on Spark and Flink. But beyond that, you really have to think about other programming systems. So for example, in Python, there's a technology like Dask. There's another technology called Ray in Python. If you are in the C++ world, there's a lot of massively parallel programming platform like libraries that you can use to run applications. But Spark is so widely used that, and you can use Python, you can use Scala, you can use Java. It has an SQL shell. We'll talk a little bit about that in a second. You can even program in C#. Microsoft has a project called C# for Apache Spark. So, and it has the ability to do compiled jobs as well as scripted jobs, meaning you could interactively do operations on a cluster in Spark with Python or especially with the Scala shell. It has a read, evaluate, print loop, REPL. And you could do stuff on a Cassandra cluster with 100 nodes or 1,000 nodes with Spark that you pretty much could not do with anything else. So in certain case, working with Apache Cassandra, Spark is the only game in town for certain things. Hopefully that answers your question.
Yeah, I think so. There is a mention of Google BigQuery is leading as present. I would say Google BigQuery is a great tool, but it also has some limitations. First of all, from my experience, Spark basically can do much more.
Yes.
Second of all, Spark is not limited to the one and only Google Cloud platform. And if you will desire to move from Google BigQuery, for example, to Amazon Web Services, now, man, you have problems because it won't work. And Spark is platform agnostic, and it belongs to Apache Software Foundation, not to a proprietary owner like Google Cloud, but to an open source nonprofit community. And from this point of view, it may be also be quite cool thing. Yep.
Yeah, and that's a good, thank you for bringing up BigQuery. I would say BigQuery is again, it's only useful in Google world, but it's more like a data warehousing kind of engine in that you connect your data and it brings it in and allows you to do queries into it. But it's more closer to, I would say, Snowflake or Redshift. Okay, and Apache Spark, although it can do that with Spark SQL, that's not the only thing it can do. Like Alex mentioned, it can do so many things, right? You can do machine learning algorithms in Spark.
Right.
You can do graph processing in Spark. You can bring up data frames from different databases in Spark and do manipulations on them, which you just couldn't do that in BigQuery. So it is a good tool, but it has a very limited scope, whereas Spark is a much broader scope, which is why I mentioned it's like a whole garage full of tools. Right, like when I'm talking about Spark, before when you said what is Hadoop, Hadoop is like 1,000 tools, not really, but it's a lot of tools, right? Spark is one tool, but if you zoom into it, there's a lot of different libraries and things that you can use to do anything with data, basically. Coming back to kind of the talk here, Spark works well with Cassandra because Cassandra scales horizontally, Spark can scale horizontally, and it works with Astra. We have some code examples that you can take a look here, but I don't want to necessarily have you guys copy and paste and run these commands. But if you go check out couple of these links. And again, the Cassandra bit.ly/Cassandra-DataOps will point you to all of these links. There's a previous talk that we did. It talks to you about running Apache Spark jobs against Astra. You can take a look at that. And let's see, here's another example. Just simple operations against Astra with Spark, right? There's lots of stuff out there. This is just one of the examples. You can run this in Gitpod. You can talk to your Astra database with Spark in Gitpod. So that's why I would recommend take a look at it. Okay. And what we want to do once you learn how to use Spark, what we really want to do is something like this, right? Get data from one place and put it into another place, right? From 1.0, insert into this database, select from this. You could do this in a relational database like MySQL or MS SQL or Postgres. You can actually do this with Cassandra if you're using Spark, right? You can say read table, write to, or you can say insert into this select statement. It is possible, but you need to connect your clusters properly. It's kind of magical. So if you were doing things like this for a mass data migration, it can work. It can also work if you do it properly with filters to do sync of offsets. But this is not the only thing that Spark can do. I'm just showing you that if you connect two different clusters, you can do magical stuff like this, right? Really cool. Again, we could talk about Spark and Cassandra for days, but we're going to move on. Another tool that, again, very few people have done schema management for, change management for schema. But there's a tool called Liquibase, which is how do you manage schema changes? How do you manage changes to a database period in Git? And their tooling is, there's an open source version of it, and that's really the only one that supports the Cassandra connector. But what it allows us to do is manage the changes to the database that we're using now, as well as the database that we're going to be using in the future. And to be able to track it properly. You want to use liquibase.org. It's the only one that supports the Cassandra connector. They do have a pro offering, but I don't think it supports the Cassandra connector right now. What does it do? Well, you have it talk to your database, and it infers the status of your database now. And then as you start making changes to it, it starts tracking those changes, and it saves them as XML files. And it can store things like exactly what happened, right? And you can change these files as well. Why is this important? As you're doing changes to your current database, your current application, or starting to involve new databases, you want to be able to redo that work in development, staging, and production, right? Well, this type of tool allows you to make the same schema changes with an audit trail of exactly who did what, right? Who made the table, and it also gives you a mechanism to do rollbacks. At first, I was very skeptical, right?
Mm-hmm.
Because I was like,
sorry, maybe you can go full screen.
Oh, sorry.
No worries.
Thank you for reminding me. Yeah, it's much easier. I was fairly skeptical because I thought I don't want a random tool to be managing my database migrations. But when I learned it, one of our team members actually learned it and started a presentation on it. I started to understand what the purpose of this tool is. The purpose of this tool is to track the changes, the schema changes. It's not going to move your data for you. It's just going to track them and execute the schema changes for you. And it does it in a repeatable manner that can be automated, right? That we've been talking about different steps that can be done manually. You can use this tool manually, but once you have the change set, you can then apply the same change set to the tool to run it the exact same way between environments. There's a couple of tables that it stores this data into. It allows you to have a consistent execution. via a database changelog table. And this is the most important part. It doesn't allow two different people to make changes to schemas in any environment, because essentially this database changelog table is used with the tool. Right? Really powerful tool. We have actually a presentation on it. You can look it up on our blog. If you're a database pro, most of the time you come up with your own homegrown solution to manage schema changes alongside with your application development team. In the CQL world, Cassandra query language world, we didn't have such a tool until the guys at Liquibase actually made it. That's really cool. I'm not going to go through all this stuff, but there's a really rich workflow. You can have tags to kind of organize tables, organize changes, and you can have even your own subcommands essentially to deploy different databases. But once you use this and you have your workflow, you're not going to be running this stuff manually. Right? We're going to be using some sort of automation to then manage the execution of this tool. At the end of the day, if you take a look at our code base, I'll bring it up right now. You're just curious how to use it. This thing can actually work with Astra, and you can just open it up in Gitpod, right? And you can walk through the examples and start to see things like, hey, take a look at the database, update my Liquibase chain set, right? And then you can apply, or you can do rollbacks to your schema using Liquibase. It's like Git for your schema. And it's managing all those changes.
Well said, well said. It's like a Git for your schema. I like it. That's incredible definition. Yeah, I will steal that for my own presentations. Thank you.
Super useful. I want to thank, shout out to Arpan, who actually put in a lot of work a while ago to learn this tool and to put this code base together. And a lot more people at our team are using it because, well, he did all the hard work. So thanks, Arpan. Appreciate your work on the code base here. Back to our presentation. Now, Airflow, I kind of mentioned it a little bit before. It's the command center. So we plan out whether we want to do an online or an offline migration. More than likely, you're going to be doing a online migration with dual writes. And it's going to at least require schema deployment. It's going to at least require schema changes. It's going to at least require some sort of offset management. If you did an offline migration, it's going to require all of those things. And especially if you're doing an offline one, you may have to do schema offset syncs and data syncs more than once until you're super happy with the state of both of your applications. Airflow is as good as the operator, right? It's a robot, and how well you give it instructions is how well it performs. You could say, well, I could just do this with my own scripting system. Well, yes, you could. You could do it with cron. You could do it with just write a bash script and run it, right, each step, and script out everything yourself, right? Or you could even use Python and script out everything yourself. But why would you? With Airflow, you're getting the ability to take a sequence of tasks that have already existing operators. There's a bash operator, there's a Spark operator, there's a SQL operator. So a lot of different operators exist to do things for you. And Airflow can manage a DAG, which is a directed acyclic graph of tasks. So if you have 3 steps that need to happen before a 4th step, all 3 things need to be finished first before the 4th step. Airflow can manage that directed acyclic graph, meaning the sequence of things in one direction. And you can do things as complex or as simple as you want it to be. Some people can use Jenkins to manage most of this that I'm talking about here. But Jenkins has at least the last time I checked, a very sequential, fairly simple sequence of steps. And it doesn't have the ability to create new tasks dynamically, whereas in Apache Airflow, you can do that because your code is Python. At the end of the day, let's just take a look at the interface. So imagine you have specific DAGs that you have created for a mass data migration, or an offset migration, or a schema migration. All of those things, you could schedule them, and you could turn them on and off. You could hit replay. You could play it right now. And you could see in the big complex tree of tasks that need to be finished, which ones were successful, which ones failed, which ones are up for rescheduled, which ones are up for a retry. And you could see it in a different view. This is the same, well, I wouldn't say the same one, but it's a different view of a different task here. But what this is showing is all of these tasks, run me 0, 1, 2, and 3, have to run before this thing can run, right? And these are just actually a part of a loop. And dependent on some logic, you can have it run something first or just skip something, right? I'm going to go back to one of the slides earlier. So you can imagine how you can leverage Airflow in basically tying all the things that we've been talking about together, right? We'll go back to that in a second. And I would say this is probably the most useful, is when you're doing these data migrations and if you're doing these syncs, every part of your DAG can be measured. You can measure how long something took, right? And you would hope that after you do a massive data migration, that every subsequent sync of data is going to be much quicker, right? So this thing can actually show it to you. It can prove to you that things are actually now quicker. And what does that look like? Well, in this case, we're doing a basic ETL with Cassandra and using Spark. And I'll take a look at that right now so you can see. By the way, all these slides will be made available online. But in this one, you can open this up in Gitpod. You can run this in Gitpod, so you don't have to install Airflow yourself. And you can connect this with Astra. And what it will show you how to do is essentially make a simple ETL where you're taking data from one table and putting into another. You're doing some operation on it. Basically looks like this, right? And what we're doing here is we're just saying, do this task before we do this task. And you can use the same syntax to create this dependency tree of tasks. In this case, we're using bash operator. There are tons of operators in Airflow. If you just Google Airflow operator, you'll find it. And so just imagine you want to do, let's go back to this diagram here, right? Let's say you want to do this operation right here, where you're maybe creating the tables, you're migrating the data, you're doing a mass move of the data, and at that point, your new database is ready. Airflow, you probably will not use to deploy your new software that's going to do reads and writes. Something else will probably do that, but you could consider it. I wouldn't recommend it. And once the new application is deployed and it's writing to A and B, Airflow can then be used to run a validation and sync process every hour, every day, right? It can do all of this for you. And you know what? This process right here, if you construct your mass move of data properly, it's probably the same thing, actually. It just has to be filtered with the right filtration criteria. And in most cases, this same operation, you're just going to be running it until you're ready to wean off of your old database. Going back here. We have a few talks on Airflow. Airflow is very popular these days. There's lots of code examples out there. for pretty much everything you're trying to do. And like Spark, you don't have to just use Airflow for ETL, right? You don't have to just use Airflow for data migration. People use Airflow for managing complex data pipelines, and it's kind of like the Jenkins for data, right? Now, let's say you don't want to do a lot of this. You need some help. Well, finally, you can ask DataStax to help you. You can ask us to help you too. But DataStax has a very specific Astra migration service. And essentially, I think that there's a bit of a consultation. They understand what your current setup is. And it's actually specifically for Cassandra, I think, to Cassandra to Astra. And what we've been talking about so far has been agnostic. You could use the same general methods and tools to move from MySQL to Astra, Postgres to Astra. But this particular kind of product service offering from DataStax is I believe, primarily from Cassandra on-premise or Cassandra on your own cloud machines to Astra. And the way that they do it is there's a technology that you deploy in your cluster, and I haven't used it, so I can't tell you specifically, but it's deployed and it's a proxy, and your application needs to be configured to be able to talk to this proxy. So this approach is actually the online migration method, the second one that we talked about, the one that we just looked at. It's just done in a different way. So that's why what we talked about at the very beginning is a pattern, right? It's a database migration pattern. And DataStax happens to use that pattern in what they call the Astra migration service. And your application will be talking to your own database. And at some point, it will do a batch update, right? Move data in mass. And then you can do dual writes to this proxy. And sorry, this is the historical data migrator. This is where you do the mass migration. And this is where you have your application essentially talking to your old database and your new database simultaneously. And after you're happy, you turn off your old database because everything is going to be on Astra. Right? So as you were talking earlier, you can use DSBulk, like we talked about. You can use Spark, like we talked about, right? The actual methodology is the same. It's just that there's a new technology that DataStax is going to give you to make it a little bit easier to basically talk to the Astra database in your own application world. And of course, they're going to help you look at the system at the very end, post-migration, make sure everything is good to go, and then they can turn off the migration proxy. One thing, again, I haven't used it because it's part of their offering. There's a data comparison that they can do using something called Cassandra Diff. That's kind of cool. So that's it for today. As I mentioned, I just wanted you guys to learn the different tools and kind of assemble them together and use them in a way that makes sense for you. There's a lot of cool stuff out there, but I would recommend taking a look at this link here. I'll bring it up again. Data Operations Guide for Apache Cassandra. And you can go to it by going to bit.ly/Cassandra-DataOps.
Maybe you could send the link to me and I will send the link to the guys.
Yeah, I'll do that right now. But that is all I have for today, Alex. Very short and sweet today. And then next week, we're going to cover true transformation.
Right. And you know what? You did a great job with Airflow. With all the other things as well. But speaking about the other things, I use it most of them already, but not the Airflow. And you completely sold it to me.
Yeah, definitely take a look at the code examples and give us some feedbacks, Alex. But yeah, if you use any of the code that's out there on Gitpod, and if you have any suggestions or questions, just ask us with the GitHub issue, or just directly contact us.
Mm-hmm. Give me a moment. I'm looking for a link. I believe you send it to me right. Yeah, just a second.
Give me 1 second. I'm gonna verify.
Ah, right. Got
Let me
it. Got it. Got it.
Got it.
Yes.
Actually, what I sent you, if you lowercase it, I think it'll work. I don't know why it Slack did some funky things.
Okay, I will fix it. Okay, now it's in Cyrillic. Won't work as well. Okay, HTTPS. Right, that's the link. And that should work. Nope.
Here, I'll just get it directly from, and I'll send it to you here. I'll send it to you in Skype, and I think you got the right link now.
Okay. Okay. Yes, that is the right link, I think. Sorry, guys. Okay, now you have the right link, and I will delete the old one, which is wrong. Boom. Right. Yes, it works for me. So that is a great thing. Have at the moment any questions on YouTube? At least everything what was asked was already answered, I believe. And that is incredible. Now, the next thing we could do for our best of the best attendees, as we promised, we will have a quiz with prizes, because you did very well listening and learning through this workshop, and hopefully the previous one as well. But before we start, please give me a moment. We will switch off for a second, and we will get back to you in a minute, okay? So hold on, and we will be there in a moment. Just a second. Okay. Just a second. Okay. are back. I hope that wasn't for too long, and I picked the good music for you to wait for us in the waiting room. I hope no one quits because now we have to run the show. So give me a moment. And boom. Now, yes, I see you are here. So let's run the quiz. It's competition time. Don't forget, you have to give the right answers, but you have to do it fast. Sooner you answer, higher the chance you get the maximum points and get the prize. Now, how to participate? I will send you a link, and that's the easiest way to jump in. If you want to jump in from another device, then you have two options. First one, go to menti.com and put the code 89856500. I will put the code in the chat as well. 89856500. Let me check. 8985. Right. Or you can simply scan the QR code next to Rahul. If you want, like my suggestion, personally, I prefer to visit Menti with my mobile phone. It's just the easiest option. So you can watch us on your laptop and answer questions on your mobile phone. So, and let me see how many people have joined us already. Okay, I need some more. I need some more. There are prizes from DataStax you can get. So jump in, push the thumbs up, and we will start in a moment. They are waiting for players to start. Question number 1. Okay, then one more, and we start. Jump in. Don't miss your chance. Don't make the competition too easy for them. We can do it better. Okay, good. Thank you. So let's start then. Ladies and gentlemen, that's question number 1. Answer fast to get more points. What is Astra? Let's start with something simple. We mentioned it this week and last week. It's a database as a service based on Cassandra. It's a local in-memory version of Apache Cassandra. It's an integrated development environment. It's a gateway to the stars. So everyone has voted, and most of you gave the right answer. Good.
Nice.
So that's good. But who was the fastest one? Who one of you was the fastest one? Let me see. And looks like it was Javier. That's a good job. Rahul is on the second place. I mean, Rahul won from the comments, not from the screen. I hope you don't participate. You are not allowed to. And Adrian takes the third place. We have more questions, so jump in. Everyone will have some chances to win. And that's going to be question number 2. So answer fast to get more points. What is Stargate? Today it was mentioned briefly, but we do mention that last week. So it's a new Mario game. It's a TV show. It's a data gateway to give you REST to GraphQL API on Cassandra. It's a gateway to the stars. This one's still quite easy. Okay, and both answers, TV show and data gateway, are right. So let us move on to the leaderboard. Who was fastest this time? Okay. So Javier again was the fastest, and Adrian takes the second place. That's competition.
Nice.
That's good. So only top 3 places are getting the prizes. Now, simple answers are over. Now you will have to think to give the right answer. Question number 3. Answer fast to get more points. What type of a schema migration requires a new table in Apache Cassandra? When changing only partition key columns, when changing only the clustering columns, all of the above. Now, that's not going to be easy. Everyone has voted, and right answer, all of the above. Schema migration requires a new table in Apache Cassandra, then changing both partition and clustering key columns, or any of them. So first to second answer are wrong. Both clustering and partition may require a new table. Well, now we will have Javier. Oh, no, no, no. At some point, I was scared what Javier made a mistake. No, it was again fastest answer. That's a good job. And Adrian on the second, Raul on the third, and SCK on the fourth, ready to fight for the third. So, Raul, take care. There is someone very close to you. Let's take a look how it goes further. Question number 4. Answer fast to get more points. What tools are not useful in moving data into and out of Apache Cassandra? TS-bulk, SQL copy command, Spark, table loader, note tool. You see, it like starts very easy, but with every next step, questions are more and more complicated. And most of you made it. That's a great job.
Nice.
That's a great job. So yes, right. Note tool is the thing what is very helpful, but won't help you moving data in and out of Apache Cassandra. Right. So, and now, oh, Rahul, it was a mistake. Now looks like SCK will use this, yeah, to jump in the top 3, and Javier is fastest again. That is something. That's a performance. Few questions in a row. That's a good result. So, question number 5. Answer fast to get more points. If you have to keep both the legacy and the new platform data in sync, which methods work? Offline migration involving downtime for every refresh. Online migration involving no downtime but a change in your software. Hybrid migration involving both online and offline data migrations. All of the above, hoping a simple backup restore at the very last minute works well enough. Right answer, all of the above. All those methods, despite their different approaches, but technically they do work for this situation, and they will keep you help you keep the data in sync. So they work, but they're different, definitely. And no, we don't think simple backup restore very last minute will work well enough. Okay. So I cannot believe Javier. It was a mistake. Unbelievable. Now Adrian gets to the first place. Javier is on the second, and George is on the third place because SCK looks like was too slow for this question. That's interesting. So we have Rahul, Casper, and SCK have chances to fight for the third place, but looks like Adrian is unbeatable. So I see no chance to make Adrian out of the top 3 at least, or maybe he will be able to hold the position. Ladies and gentlemen, that is the question number 6. 2 questions left. Now focus, we proceed. You know what to do. Answer fast to get more points. What tools do you think are useful in online migration? Table, SQL copy, TS-bulk, Kafka. Table, SQL copy, TS-bulk, Kafka. Okay, that was a complete wipe. Only one person made a right answer. What you missed, what most of you missed, is an online migration. For online migration and online sync, DSBulk won't help you. It's a tool for offline migration, which is very helpful, which can be a good addition to the Kafka Connect. But it's not really a tool for an online migration. So only one person gave the right answer. And who was it? Who made the right answer? Casper.
Nice. Good work.
Nice. That took some time, but Casper now jumps directly to the second place with the fastest and the only right answer. That was very interesting. Now, Adrian, Casper, and Javier are keeping top three. And we go directly to the last question. So, brief out, breathe in, warm up your fingers, get ready. Ladies and gentlemen, we start the last question of the quiz for today's second episode. Second episode out of three for our data migration to the cloud series. And here we go. Answer fast to get more points. What is not the goal of data operations in a cloud migration? Automate repetitive import, export, and syncing tasks, build our software and release it, allow automated quality control in each release to save time and money. What of that is not the goal of data operations in a cloud migration? Okay, you know what? That's quite an interesting outcome. No, data operations are not responsible for build and release of the software. This question was a hard one indeed. But indeed, data operations goal is the primary. The goal of it is to save time and money and make your application running in the cloud with all the data stored where it should be stored. So the first very goal of the data operations is to save time, money, and effort of your team. And then it allows for automated quality control in releases for data, and it allows automated repetitive import export sync tasks, but it's not for building and releasing software indeed. Now you know what, I cannot push the button. I'm scared to
I'm
see what will
curious.
happen next. Yeah.
Curious.
So, okay, Casper, slow but with no
Nice.
mistakes. Casper,
Nice.
that's a great result.
Wow. Good work. Good work.
That's a good work. Take a look. Never fast enough, but always with the right answer. That's a very good approach. Almost always, almost always.
Mm.
Okay, so Casper, first place. Adrian, second place. SCK, third place. Please contact me. Actually, it will be, I believe, easier if you contact me at datastax.io/Alex. I will, that is my link. So contact me on LinkedIn. Link is in the chat, and I will take care what prizes will be dispatched to you. Don't forget to make a screenshot of your winning screen with your place, first, second, and third places, and to the others. Don't be okay. Of course, it's always not the best feeling to lose in the competition. I do know that. I lost a lot of competitions in my life. Win some of them, actually, yes, too. But what matters is you're learning something new today. You become a better version of yourselves as an engineers, developers, administrators, architects, and that's what really matters. Not the prizes from DataStax, although they're quite nice. Better luck next time. We have next workshop of this series with Rahul in next week, Tuesday. But we have one more workshop out of this series for another things tomorrow, actually. So you can subscribe to our YouTube channel, jump in tomorrow, and try to win the prizes in the next workshop, which we do tomorrow. And I believe that was it. Do you have any more things to say? Any more slides?
No, that's it.
No?
Yeah, looking forward to talking next week about what true serverless transformation can look like, where everything is in the cloud. And we're going to talk about some practical things that you can do today. But really, what I would like to do is to open up people's thought processes and have everybody think outside of the box. Like, what does an amazing serverless platform look like? So lots of cool stuff to come next week, and yeah, looking forward to it.
Hmm. Great. So, thank you so much. And that was incredible day, incredible workshop with you today. Thank you so much for joining every one of you. And see you next week or maybe even tomorrow.
Thanks so much, Alex. Appreciate everything, and see you guys next time.
Thank you. A little bit of music in the end, relax and enjoy. You spend this time very well.